So on June 11th, 2020, OpenAI officially released their base ChatGPT 3 language model, which was a great leap in AI technology. However, then GPT-3 confidently argued that 9.11 is greater than 9.9. 6 years later, on May 20th, 2026, a new generation of OpenAI models disproved the 80-year-old conjecture in discrete mathematics by one of the greatest mathematicians of the 20th century, Paul Erdős. 5 days before that, Pope Leo XIV released their encyclical Magnificat Humanitas, warning to safeguard the human person in the time of AI. On 2nd of June 2026, the International Mathematical Society published the Leiden Declaration, calling to address the challenges posed by the use of AI within mathematics research. And today, on July 8th, at the 25th European Young Statisticians meeting in Vilnius University, Faculty of Mathematics and Informatics, I, Dr. Aidas Medžiūnas, am joined by accomplished researchers in the fields of statistics, mathematics, and astrophysics to discuss the challenges of AI to science and society. So let me introduce the panel. Dr. Xiaocheng Shang, University of Birmingham, United Kingdom. Dr. Marta González García, International University of Valencia, Spain. Dr. Carlos Escudero Liébana, National University of Distance Education, Madrid, Spain. And Dr. Balázs Csanád, Institute of Computer Science and Control, Hungary. So I want to start our discussion with a warm-up question. What does AI use look in your home country, at your university, among your students, colleagues? How do you use AI yourselves? So anyone can start.
Yeah, I can make a start. So I think in the UK, students use AI quite a lot. We even have an official subscription of the Microsoft Copilot for university staff and students. And yeah, I think it's being used quite widely. And for myself, I have been only occasionally use it, for example, to polish some English or some emails, but only very recently, probably 3 or 4 weeks ago, I think that's was the first time where I used AI to kind of help with some mathematics, because I want to solve some very difficult PDEs with some, for example, I will talk about in detail on Friday, but the problem I had was that I have like very difficult PDE to solve in general, but we can try with some particular form of solution to see if it works. And but it was very difficult or cumbersome to work by hands or with pen and paper. So I tried to use ChatGPT first to help with. I think originally for very simple ones, it worked quite well. So I kind of trusted a little bit for the very first time. But then for some more complicated cases, it produced some sort of, I don't know if I can say the word nonsense, but like, because the nice thing about my problem is that I can check the solution ChatGPT provided with some mathematical software like Maple. I can check if it gives me the exact or correct solutions. So I can go back and forth to tell ChatGPT it is incorrect. So you should prove it. And then after a few rounds, and also because I did not subscribe ChatGPT Premier, so I had to wait for a few hours each time when I ask them, maybe 4 or 5 questions. So I used Microsoft Copilot as well. So kind of I combined both of them. And eventually, after a few days, mostly because I had to wait a long time for the ChatGPTs because I didn't subscribe it. After a few days, I actually managed to get an almost automatic program within the Maple software that can automatically give me some, for most of the problem I gave it to them, it can give me automatic kind of workflow to give me the solution I was looking for. It worked quite well. So I was kind of amazed that it maybe saved me at least a few days of time working on using pen and papers. And the nice thing that I can check almost immediately in Maple rather than writing a number of papers to check and without a guarantee if it's correct or not. So I think so far, that's my only use of kind of mathematical proofs or helps in my mathematics. But apart from that, I mainly use it for polishing emails, for example, and some documentations because I'm also the program director for 3 master programs in the University of Birmingham School of Mathematics. So when it comes to programs, vision, aims, learning outcomes, because I direct 3 of them, so it can be quite a challenge if I work everything by myself. So I think I found it quite useful to ask them to help as well. But I have to give them some, and documentations first rather than coming up with something from scratch. So far that's my use of AI in my work and in my daily life. Yeah.
Very interesting. Marta?
Yeah, so thank you for breaking the ice. So I use it to code, basically, to help me code and produce less dirty code, let's say, kind of checking the input parameters, more documented, those boring things that we don't really want to do by hand, but we should probably. But I have I don't fully trust it, so I really double, triple, recheck everything because sometimes you ask it for one thing, it gives you some code that doesn't really do what you asked it for. You tell it, that doesn't do what I asked for. And yes, you're right. Now this one actually does what you asked for and whatever, but for that, also to correct my English, of course, and doing images for talks, maybe. I think that's, and yeah, sometimes searching for literature, but it's basically when I don't really know what to search, like in consensus or something, because that's based on papers and it gives you actual papers as references that afterwards I can check if they're actually what I want or something like that.
All right.
Yes, well, thanks. I use it mainly for checking the documents I produce for the English grammar and also the mathematical correctness. Also, this is really not trustable. I mean, it's like a sparring, but I mean, sometimes it gets some typo or something. Sometimes it gets wrong correction. So it is well written, but it says there is something wrong. But it's good to recheck anyway, right? And in our university, it is used really massively. Yes, I noted this with this master thesis and every kind of thesis that are the students have to write when they finish a degree. Okay, we found really a jump, a discontinuity in length and quality of the thesis. Yes. Also with the examinations, we are an online university. Okay. So we have examinations online during the semester, and at the end of the semester, all the examinations are taken in a classroom, okay, which is set up specifically for the excess exams. And okay, you have the statistics of how many people you have in the class and how many people go to the exams. And also there was a big jump, like more than double started going to the online exams. And also the results of online exams were way better. Okay, and this was not correlated with the performance in the on-site exams, right? So basically we are now removing every kind of online examination, and except for oral presentations, which can be held online. We didn't see any problems in that yet. And this is, well, the university is now kind of transforming in this respect, because I mean it's used massively by students. And well, myself, I noted that to use it, of course I don't know any program, every program. I mean there should be more sophisticated software probably, but the one I tried for research is not that good. I mean it commits a lot of errors. For instance, I mean it's for the Ito integral, say, knows the basic, I would say. If you ask for something really, high in the theory, then it's not good at all. Probably because there are not enough documents out there, and it works statistically somehow, right? But for undergrad mathematics, it works very well. I think that there is a lot of documents produced in universities all around the world. And well, I mean, of course, the students noted this immediately and started to use it. And now we are trying to rethink evaluation, so we can evaluate something, right? I mean, the student's performance, not the student use of the AI software.
Right. Dr. Csayi?
In our institute, I think the AI are used more and more, and the younger the colleagues, the more they use AI. Regarding myself, I also use like often for grammar and stylistic improvement refinements. It's very useful for if you're writing LaTeX, you generate nice macros and Tix figures. It can help a lot. It can help in numerical simulations. If you have a nice theory, then it can help you draft like a code to test it. Of course, then you have to manually somehow improve it or further develop it, but it saves a lot of time. And it can also optimize your code if you have some numeric experiment and it doesn't work as fast as you think it should. You can ask them to optimize your code, and it's quite useful. Regarding like research questions, it's quite you should be very careful how to use it. I think my colleagues mainly use it as a lottery machine. If they stuck in a problem, they start chatting with an LLM, and it randomly generates some ideas, and maybe most of them are rubbish, but sometimes they have some connect two fields that gives a spark or an idea. Oh yeah, that should be worth checking out, and that could be useful. And yeah, for universities level problems, they are quite good and they can solve efficiently. So that's a problem for giving homework to students.
So I want to come back to what Dr. Shang mentioned about this premium version, right? But there are premium versions for individuals, but there are premium versions for countries, right?
Okay.
Because the discrete mathematics conjecture, which was proved, of course, was not proved by this basic version.
Definitely not.
Right. Yes, it's a super duper ultra version. So the question is, what does it mean for us personally, for our students who do not have $20, $30? And what does it mean for our countries? Do they have money? And even worse, what does it mean for Europe, which does not have an AI model, right? All models are either Chinese or American. So
the French are not there?
not there yet. All right. Well, Lithuanians don't have it. Spanish don't have it. So what does it mean?
Europeans here.
Yes. But what does it mean? What does this tier system mean for the future of science, education, and so on and so forth?
I think, as far as I know, all my PhD students have subscribed for the premium version. It's just me. I haven't. Because I think so far, as I mentioned, I only picked up really for mathematical proofs only 3-4 weeks ago. I found it useful, but in the sense that I know how to double check it. I just put the results into the Maple. If it gives me 0, yes, that's great. If it's not 0, then something is wrong. So, but beyond that, I don't yet have a fully confidence, as some of other panelists mentioned. I don't have full confidence in some maybe more open mathematical proofs or more open mathematical challenges. I actually tried with my on-premier version of ChatGPT. I played with asked it some questions that I know quite well in my own research area. Maybe I did not train it very well, but it did not give me very satisfactory answers. So I don't fully trust it yet. Maybe that's the reason why I haven't subscribed yet. So, but I think some of my students found it quite useful in terms of help with coding and creating nice images, for example, and maybe help them think about how to set up some numerical experiments to for some paper reviews, for example. But I think, as I mentioned, there are maybe some sort of unbalance between countries, and even in one country, for example, our university subscribed this Microsoft Copilot, but I don't imagine all the UK universities would subscribe something similar. So I think there's definitely an unbalance in there. I don't have a solution, but I can only talk from my own experience and also my experience with my students. I think different people might have different opinions. Yeah, but I think for myself, I don't fully trust it, as some of other people mentioned, unless I can, for example, verify it. Otherwise, I wouldn't, for example, I think for some basic mathematics undergraduate level, I think it's probably fine. But in terms of personal research, more advanced topics, I just don't fully trust it. Maybe the super duper ones will do a better job, but my own subscribed version definitely will not, I think.
Comments about levels and accessibility?
I believe there will be, probably you have already differences between those students that have access to the nice ones and the ones that don't. I'm pretty sure that the ones with just access to the free version are having much harder time. From comments from my own students, it's like, yes, I'm willing to pay the 20 euros a month subscription because it saves me a lot of time. Kind of, I input the notes, and it creates summaries for me, and that's what I get. And so, yes, I believe those students have it in some ways, in some aspects, easier. But one of the things that worries me most about that thing as a teacher is that I believe you need some roughness to learn and to develop. So you make everything smooth, you make everything transparent, you take out the effort, the thinking about it, the getting it wrong, the sweat of it. You won't learn. You will have the product, but you will get a very nice paper, undergrad paper to give to your teachers. You will get a good grade maybe, but probably you won't learn. So that scares me a bit as everybody uses it, as humans. Are we going to stop kind of learning? Maybe I'm a crazy person that like when calculators came out, people will stop doing additions, you know. But I'm old now, so that's what worries me, if we stop learning.
Reactions, ideas, suggestions? What to do?
I don't know what to do, but as I understood, you are afraid of that this increases the inequality between like poorer and richer countries or people. There is some danger in that for sure, but I think the technology develops extremely fastly. So the free version today is like as good as the pro version a few years ago. So I don't think that it's a very serious issue, but of course we should be aware of that.
Right. Well, so this is, of course, the software part, right? But you need these gigantic data centers, which are very expensive and are not very good for climate, right? Here in Lithuania, the weather is nice and refreshing, right? But our Spanish colleagues came from very, very hot Spain, right? So what does that mean for us? That we want to stay on edge, but we have to build these gigantic data centers, which now compete for electricity, for water, for resources, and of course everything is heating up. But it's intellect, but it's proofs, it makes everything better, smarter, faster. What about that dilemma? What's the answer?
You should simply set a financial market. Put a price to electricity, to water, and to the rest, and it will work autonomously.
But if it's you competing for water with data center, what does that mean for you?
This means, just for me, it's me, only me fighting against the water, then I will move here to Lithuania, where it's full of water. But it's my choice also, I can move to another place.
All right.
So I think this is the, yes. This is the most optimized way of dividing resources, yes? To set up a financial market and put prices to everything.
All right.
Yes, I mean, for me, it's something experimentally clear.
So, and if this planet gets too hot, we move to another one.
If this planet is getting too hot, I mean, I don't see that is coming. But also, if it were coming, we would adapt.
What reactions, comments about that?
Well, I believe some of the costs of artificial intelligence are externalized, the environmental costs, notably. So that's why maybe he's right, and you have to put the price tag on them, so they are included in the metric. Because at this point, I believe they are not very included, and that's why the scaling is not being done maybe optimally. But I'm not sure it's an AI thing. It's also a garbage thing, and it's also putting satellites in space thing. There are some, if they are not in the bottom line of specific people, those costs don't exist, even if the rest of us are paying them.
Comments?
I think it's not just about the AI thing. I think it's a global sustainability issue. Like I don't remember the name of the conference now, but I think annually, I think many of the country leaders, they will meet together to discuss how we can, improve sustainability across the globe. I don't remember the name, but I think they do it annually. A couple of years ago, it was in Dubai, and it was in Brazil, and a few years ago, it was in Glasgow. I think we probably should treat it not separately, but probably as a global sustainability issues, where global leaders can kind of look at it together. Maybe that's a good way to go.
All right. Interesting ideas. I hear you being still very optimistic in the sense that, do you believe that mathematicians are safe? That's the question from AI. Do you believe that, I don't know, in 2-3 years, all proofs will be made by ChatGPT? Okay, not 3 years, 5 years. Not 5 years, 10 years. So do you believe that it's coming, or we are safe and human component will always be there in mathematics? What are your ideas about that?
I think we should change. We should evolve or die. Yes, as this has always been the same, I think. Yes, I mean, the university is changing. As to research, I think we are not in danger so far. But the way we teach undergrads and evaluate them is something that needs to be changed in the short time. Otherwise, the university will make little sense. Because still master degree, PhD is different. But I mean, it's, for instance, in Spain, we cannot have as many universities as we have today if we just say don't have undergrads, which are the basis of the pyramid of higher education, right? For research, maybe we'll get the time that AI does part of our job, but then we have to evolve and do something else, right? Like, I think it's not the first time we do this. If you see what classical mathematicians they did, they were looking for explicit solutions, they were looking for results that for them, it was impossible to get them by other means. Now we don't need so many explicit solutions, we don't need other results that they had, because we have tools that, I mean, you can solve an algebraic equation in fractions of a second, right? So this if you solve an algebraic equation explicitly, then in terms of radicals, sometimes this adds nothing to the numerical solution, which you get with any precision, for instance, right? And many years ago, being able to compute integrals, these primitives, was like an art. Now it's nothing. I mean, we have this computer software for solving primitives since decades ago, and it does it better than any human being. But I mean, mathematics didn't stop. So it evolved, and it was looking for different questions. And I think it should continue evolving. So I don't think this should be a problem unless you want to stay the same and do, okay, I want to do like the oldest professor in my university has been doing all of his life. Then probably you're in a trouble. But if you are ready to evolve, I don't think there should be any trouble for you.
That's
My view is that I think for high-level advanced research topics, we definitely still need people, because AI always believes they provide the solution. But actually, many times it was incorrect. So we definitely need the people at high-level research topic to kind of verify if it's indeed correct or not, because AI always thought it was correct. But for like relatively low level, for example, undergraduate or even lower level, I do feel that we may need to think about what's the best way to going forward. I spoke to a head of school of mathematics in another UK university a few weeks ago. He was thinking about whether or not we should adopt like an open classroom approach where students can watch tutorials online. I think we do need to think about how we can best deliver the educations to the students, because they were also thinking about why are we still paying so much money, more money than before, while we have such powerful tools that can teach you basic mathematics, for example.
I want to play devil's advocate, right? Let's keep education on the side. Of course, we will discuss it. But what happens, and it does happen with humans, right? What happens if the statement and the theorem is correct, but the proof is so complex that human mind is incapable of understanding it? Because we do have proofs, right, in mathematics, which are so long, which involve, right, separate new kind of mathematics, right, that only dozens of people in the whole planet understand it. So what happens with us humans mathematicians if AI starts giving results and the proof goes over our little human heads? What then?
I think it will be very, sorry,
Go ahead.
sorry, I think it will be very difficult for one single mathematician or person to verify if the proof is correct or not, if it's super complicated. But I do think with the help of maybe a few more people together, even the top level scientists together, we should be able to verify even the very complicated one. Because as I mentioned earlier, we cannot just believe what AI says in terms of proofs unless we have some human verifications. So that's my view.
Marta?
Well, I was thinking that we kind of need to create tests, maybe smaller tests for singular steps or something like that, empirical tests, whatever tests, maybe even if we don't understand what it is, we can check something.
If it's not humanly checked, then we should not accept it, I think. But it doesn't mean that there is no way to check it. We can ask the AI to break it down to a lot of little lemmas, which we can check individually, and we can ask them to simplify, give picture overview. So we can not just take the proof as it first gave. We can make various requests to make it understandable for us. But if we don't understand it, we shouldn't accept it, I think.
Agree, definitely agree. Yeah.
So mathematics is correct only if human agrees with it, or like with the proof. That's a really interesting concept.
Yes,
right?
With the current technology of this kind of...
It can be correct, but maybe we shouldn't accept it.
But what do you mean by that? Because, for instance, when Perelman solved the Poincaré conjecture, for years it was not clear that it was correct, right? But maybe it was correct. Only after many years, some geometers decided it was correct. But still, it was not well written. So some missing steps, some...
Yes, Dr. Balázs wants to react. Yes, please.
It's a difference between correct and we accept it. It could be correct. I don't say that it's incorrect.
But it's it's only a tiny fraction of geometers who decide it's kind of correct, because even there are level of corrections. I mean, maybe it is not written with a perfect detail or whole rigor, but it can be easily rigorized, or the missing steps are easy to complete. And finally, it's just a bunch of people who decide this. It's not like humans or something. And it could perfectly happen that in 50 years, other guys decide that it wasn't true. This wasn't correct, right? So, I mean, I don't think there is that big difference between the machine and us already.
So I know we are all mathematicians here, and we have 40 young statisticians here, and mathematicians too from 25 European countries, and this is a faculty of mathematics. And for us, proof and the holiness of proof is very clear, right? But I think we should explain ourselves. So can you help me why we separate result and proof? Why because for the rest of society, they care about results, right? The result, it's correct. And we sit down here, and now we had such an interesting and fascinating, right, discussion about the proof. So why proof is so important? It's not. Okay, I'm devil's advocate here. I'm like, convince me, please. Right? I have results. I have amazing results. Everything works. And you come to me and you say, no, I need proof for that. So why it is important? Can you try to explain?
For me, it's for when things don't work, because you need to figure out why. I mean, everybody worries about the existence of solutions when your method's not working, it's not finding it, it's not converging, is then when you need the proof because you need to figure out how to correct your method.
So empirically, you cannot verify or confirm anything. It's only you can only increase the probability that it might be true. So what with mathematical deduction, you can say that it's 100% true. That's fact. So that's the only way to achieve certainty, by deduction. There's no other way. You just make experiments and try simulations. It seems working. It's not a guarantee.
Yeah, I definitely agree. I think, as you mentioned, the proof may not be as important for normal people, I mean practitioners. As long as the results works well, they're happy. But I think it's responsibility of mathematicians, statisticians, who should kind of care more about the actual mathematical proofs. And as Balázs mentioned, for something you just cannot demonstrate by experiment. It has to be done by rigorous mathematical proofs.
For me, the proof is not the most important thing.
Finally, friends.
Yes. Yeah, for me, I think it is important to give a rigorous proof when there is a problem of understanding in the literature. You find, for instance, papers in physics which I read and they are contradictory and they are giving pure formal arguments just to say the other guy is wrong and there is a complete mess and no one knows what is really going on there. Then you have to write everything in precise language and give a proof. So this is the only way you can convince everybody in what is the right thing, okay? And sometimes you even don't get it right because they think it's too mathematical or something. But I think this is the right way of the proof. If you go to the applied science and you see that they have 1 million simulations, everybody agrees, and you have a full proof of that, which is very technical and very complex, and adds nothing to the knowledge, then for me it's a minor result. It's not important. For me it is important when you add knowledge. But this is a personal view, of course. I mean, I know.
The proof always has knowledge. It shows you why it is true. The simulation just shows it looks true. So I think it's for me, I disagree with you.
Yes,
Proof
no.
is the main thing.
It always adds something, but for me, it adds a little only.
But it helps you understand why it is true. It just looks, the results looks good, it's why.
I mean, of course, it depends on the level of analysis of the numerics. You know, some people, they just do these very naive simulations, but some people, they do a very serious work, and indeed, they don't have the proof, and you can do it, but sometimes it's not really, I mean, adding much. You always add a little bit, right? But I mean, then we have to see the bigger picture and see the cost of opportunity, right? We are investing a lot of personal and public resources in making this tiny advance, while I think we can do something better in the sense that there is something which is really unknown and people are fighting, they don't understand what's going on because they don't really understand what the stochastic integral is or something, and you can clarify this to them. But of course, this is not say revealed truth. It's just a personal opinion, which can be, of course, wrong, or I mean, not sure about any other one.
I think the disagreement comes from the fact that you care more about the practical relevance.
Yes.
But I think for me, it's like the scientific or theoretical relevance is quite important. And in the long run, I think it also becomes practical. So there is a saying that nothing more practical than a good theory. So if you understand what's going on, you will have even better methods and even better results in the long run.
Yes, that could be, but for me, the cost of opportunity is huge to do that, and I think this is not the optimal strategy, right?
Yeah, I think that's why it's not everyone's responsibility to prove the mathematics theories.
But I'm not sure. I mean, I think everything has a place because you don't know what is going to be useful in the future.
Right.
I mean, it's the basic against applied science once again, and a lot of mathematics that were developed just for fun. Prove very useful afterwards.
Yeah, but it's a really minority. It's very few of them, and mainly they are developed by public money. This is money not of the researcher himself, which introduces a bias. It's like if I go to a supermarket and I buy random products, I will end up buying something that I didn't know and is very useful. But I will lose so much money to get that I would never do that in my life. I will always buy what I know it's fine for me and for my house, right? And I never get to know this wonderful product. But I use the money in a much more efficient way than buying randomly. And this is what everybody does, right? But for research, it's different because we have these, say, incentives that change things. I mean, it's if you yes.
For research, you ask for a project, and
Right.
you kind of have to sell in some the project to the funding agency and say it's going to get some results for science, get whatever the metrics are, and every system is
It's not their money anyway.
corrupted.
You know, you can do research for the private sector and ask the people, you give me money, okay, crowdfunding, and I will do these theorems for you, okay? So you see this method that works very well in Volkswagen for the cars. You know, these cars work greatly, but I can give you a rigorous proof of that, but you pay me. I don't think you're getting €1.
So
Yes,
I
but
would.
I mean, the objective of Volkswagen it should be different than the science planner of a country.
I think we are.
I mean, the incentives should be different for an enterprise than for a university.
Well, I mean, it depends, right?
So let me expand this idea because it's a really interesting idea and really interesting imbalance, which is mentioned in Leiden Declaration too. So most of the research in AI is made by private business now, right?
Yes.
And of course, we have interest in university, right? And we had ideas about universities adapting. At the same time, of course, university is carrying this higher purpose, right? It's not only result-oriented. It wants to, grow the knowledge of all humanity and to introduce new values and to educate people, right? Whatever that means, right? So, but there is this imbalance. No university has amount of money which all those private companies has. So, will we survive? Are we still needed? Right? So what does it mean for us? How do you feel?
Of course we will survive. Of course we are needed.
Please.
I know personally several people who work in these top AI companies, even work on these top AI products, and were all educated in our education systems, and they live off what they learned and what they did during their PhD and so on. Of course, they develop new theories, but not fundamental, like basic research. They mostly applied research. And if you would cut the funding for the basic research, is like if you would cut the roots of a tree, it will eventually die. And maybe the fruits are made by the companies, but the roots, we are the roots, and we are needed.
Do you agree?
I'm happy to see that yesterday when I said that academia was very anti-capitalistic, I was right? Yes, I don't think, there is nothing evil in private companies.
No.
I think
I didn't say that.
Yes, no, but it's kind of the feeling, if you say they go for profit and we go for...
Either.
No, but Aidas said, that they go for something. We go for something which is superior, right?
Different, maybe.
Yeah, exactly.
Yeah, we are going for different. And is there a value for it?
Yes, you know, there is a Spanish movie I watched a long time ago, and the guy said something which was very mysterious for me at that time. Is there are two types of people: the people who want money and the people who don't know what they want, right? So if you go for profit, it is clear what you want. And in general, if you are a company, you try to serve your customers well, because the better service, the more profit you get. Okay? If you look for something which is superior, then probably you might get lost in these unclear ideas. Okay? Because after all, money is a measure of how satisfied the people is with you. So if you give them a product which they like very much, they are willing to give you money for that product or service. If you say, okay, I will give you something that you are not able to appreciate now, but maybe in the long term, you will appreciate it. So somehow I have to be funded. You know, this is something that is difficult to put on a solid base, right? It's like a bit mysterious.
Reactions?
So I believe it's good to have a metric,
Yes.
and it's good to I mean, there's nothing inherently bad to want to have a life and to want to have a good life and to want to profit and to want to your work to have results. But if we do lose, I mean, if we forget the process and just optimize to the metric, sometimes we lose things along the way.
For instance?
that we assumed,
Yes.
but are not included in the metric. For example, possibly if you don't include in your metric, I don't know, I'm in the environmental thing, you know,
Yes.
throwing all your discard things, just throw them by the window. That will be the most cost-efficient thing for you. If you don't, I mean, if you don't include in the metric that you cannot be dirty in your surroundings, the best thing for you is just to don't worry about waste management. You throw them in the river.
This is why there is because there is no price for dumping garbage. If you find the people who does this, there is a price. I then don't do it.
Yeah, but I mean but I mean that's the point. If the only thing you're counting is money, but not everything is in the metric. I mean, you have a metric, but if you don't include everything, you're losing stuff. And I believe that basic research should be included in the metric too, somehow, not just results, because otherwise it's like what we were saying before. People are producing papers, or papers are being produced, but people are not learning. So
Yeah, Dr. Shang?
Maybe on slightly different point of view, slightly different angle is that I think for private companies, it's perfectly fine for them to maximize their profits, and they produce very powerful AI tools that help our daily lives, help our research, save us lots of time, which is fine. But for university, the goal is to educate the students, to train the next generation researchers who can, again, also help with the top AI companies to, further advance their tools. So I think it could be a very nice ecosystem where both university and the AI companies can both survive. I think it will work well. Yeah, I don't think that one of them will have to die or something, but I think it's fine for both of us to survive and flourish.
It's the symbiosis.
Yeah, very good. So before the question part, so we have 40 young researchers.
And
Oh, yes.
sorry, it's something that you just said, because if the metric is profit, you say that they are doing things to help people and they get a profit. They are not doing things to help people. They are doing things to get a profit. and helping is kind of a byproduct of your profit, then sometimes it's not forcefully helpful. Maybe I'm not saying it.
No, of course.
I mean, if what's supposed to be your mission is a byproduct because your only metric is profit, I don't know how it works.
No, I don't think so. I mean, it's so money is just a measure of how the products and services you deliver are wanted by the people. So you have to do something which is very good for the people if you want to get a lot of profit. Otherwise, people will not buy your products.
So you think people cannot buy bad products?
No,
So, I mean, no?
no, but this is kind of yes. But what is bad and what is good? Yes, this is like a Platonic idea, right? This is this English saying, "One man's trash is another man's treasure." So something which is very good for me, it can be very bad for the guy who is walking down the street, right? So, but if some company produces something, maybe for you this is rubbish and you wouldn't put 1 cent on it. Maybe I think, wow, this is a wonderful thing, right? It's like TV channels. They are always offering me TV channels that I can pay for and see all the football matches. And I stopped watching TV many years ago. Also football, I don't see any football at all. So when they call me and they say, I offer you this, I say, no, I'm not interested at all. And they are, wow, I don't believe it. This guy is lying to me. No, it's true. But this doesn't mean that football is rubbish. No, there are, so many people interested in that and willing to pay T-shirts, willing to pay huge amounts to go to the stadium and watch the match. So,
Right. So I think we can round up this part of discussion before the final question I have to you is that these are the questions we should ask, right? I think this panel shows that there are many ways and many approaches and many questions which should be answered because AI is a question being asked for university. What does it mean? Why do we need it, right? So ivory tower has to open its doors and let people in because otherwise, right, it's a very interesting, right, discussion. But as I said, we have 40 young researchers listening to you. Yes? You already have your positions. You already are on the path. Yes, you are already a keynote speakers in 25th European Young Statisticians meeting. But what about them? What is your suggestion, your warning for those young people present? What should they do? What they shouldn't do, right? What would you do if you were in their place now where this AI technology, it's not going away, right? It's writing proofs, it's giving easy answers to exam questions, right? So what should they do and what they shouldn't do?
Maybe I'll start at first. I think my advice would be, it's definitely fine to use AI to help with the research. I even encourage you to do that because just many students, many people, they all use this. It will save you loads of time, but you just have to use it with care, particularly with mathematical proofs and the things more scientific. You just have to be used with care. For example, in my case, I'm lucky enough so that I can double check the results using Maple. But maybe in different people's field, it's more challenging to verify your solutions. But you just cannot blindly trust the results they give. You just use them with care. That's my advice.
Marta?
I think they should do what they want because that's why they are young and smart. But if I have to say something, then I'd say use it, but don't do the black box thing, because otherwise I wouldn't trust that the objectives of the people holding it, which are not, as you were saying, maybe are not aligned with with yours. So use with care.
Yeah.
Dr. Liébana?
Yes, but you mean in every direction?
Yes.
Not specifically in artificial intelligence.
They are yours. Share your knowledge.
Yes, I can only tell you my experience. As I said today, when I started, that was very idealistic, and I thought that mathematical physics was like some top field, which was not contaminated by money and all these terrible companies, and really by miracle, it was really say last deviation who brought me to finance. Basically, I taught financial mathematics because no one else wanted to do it. Okay, and I was like the youngest guy in the department. So you go and do it, and I discovered a fascinating new topic, and I kept it for years. I kept it only on the mathematical level, and only very recently I started to collaborate with companies. And for me, I think it was the right evolution to do. I think this is a personal belief. Again, it is not a revealed truth, so I may be wrong. I think that the future of the university will be more and more to collaborate with the private sector, be open to collaborate with the private sector, not one in particular. Of course, if you don't like finance, you think this is the sign of evil or something, just escape from finance. There are many things to do. You can work with artificial intelligence companies, which, as we learned today, they are evil too, right? No, I'm just kidding. But there are many sectors you can try to cooperate with people doing agriculture or whatever. I think this is the future of the university. But again, this is just my personal view, so I may be wrong.
Dr. Balázs.
I try to be brief, so I also think that they should use it, but like in every aspect of your life, critical thinking is quite important. Question everything and use AI to enhance your thinking, not to avoid thinking.
Right, thank you very much. So now we have a microphone somewhere.
Here.
It's here, huh? You see? So you raise your hands and ask all the panel or some members in particular, or you want to say a comment, so you are encouraged to do anything you want. This is for you.
So my question goes a bit back to the beginning when we discussed the costs of AI. So I believe that in maybe 5 to 10 years latest, AI will be able to write papers. But there are different versions of AI. So there are cheap ones, there are better ones where you pay $20, or you have ones where you pay $200. The best one is the most expensive one. And not everyone in the world can afford the most expensive one. So does that mean that the richest people are the best researchers in the future?
Please.
Well, I think this is not going to be in the future. It's already now, right? Because you go to Princeton and they have top mathematicians there, and they do, say, world-leading research. And Princeton is a university only for rich people. So I mean, but I think this is not new. This has always been this way, right? And I mean, it's not necessarily bad. Also.
Reactions?
Well, I have, it's not exactly a reaction. It's I'm thinking if it's the AI writing papers, who keeps authorship then? Is it mine if what I did it's a prompt? Well, I don't know.
Yeah, it might be that I think that the unbalance is just everywhere. For example, at the moment, many years ago, rich people can go to private university like Princeton or the Ivy League university, for example, Oxford, Cambridge, but the less able ones, they just cannot afford them. I think just another form of imbalance in terms of the AI machines. And of course, as you mentioned, some people may be able to pay for the 200 ones. They maybe get more accurate results, but I don't think that will replace all the nice papers we write nowadays. I think they may get a bigger help in terms of the AI, but I don't think they will replace everything we do in terms of researchers. That's my view.
Well, I would just clarify. Of course, if the point is the best paper, right, the smartest theorem, then of course it doesn't matter who writes it, right? That's it. But what about social function of science? Raising people up, right? We have millions of stories. So will it be a loss, or right? That because it accelerates this, right? You still can go to Princeton being poor, right? But yeah, there's still a small chance.
Yeah,
right?
yeah.
But with this AI revolution, is that door closing? And again, are we losing something, or it's just realities of life, right?
So I think in the top tier research, the imbalance might increase, so the inequality. But maybe for the not top tier research, but universities students level results, it can actually decrease the inequality, because even the free versions of AI nowadays are perfectly fine with the graduate level maths. So you can, if a very poor student have access to it, which now is not a big deal, then he can interact with it, can learn a lot from it, and maybe it can help him or her or to have a higher career and get out of the poverty or something like that.
Yeah, can I just also add, I think it's not necessarily the more money you pay for the AI thing, you will get a better help. It's more about how you actually train the model, how you give them prompts properly. Not about, I never use the expensive ones, but imagine if you give them rubbish prompts, they will probably produce rubbish as well. But if you give them very smart, nice prompts, even for the free version, you maybe get some very nice answers. So it's not just about the money you have to pay. All right. Yeah.
I wanted to ask, during your discussion, you mentioned that only the proofs that are considered correct by people would be accepted into the knowledge base of our framework science. But as complexity grows of the things that we solve with AI, the number of people probably will stay the same. So there is an upper limit for the rest of the society. They in time probably won't have work. They produce something, but the number of people who verify is the same. And that creates, I believe, tension in society as well. And how, in your eyes, that will resolve eventually?
I think Balázs already mentioned this, but I think probably over the time we will have a pool of proofs that are AI proved but not humanly proved. I think that number will grow. I think now we just have unproved, proved. But in the future we'll probably have a category where it's AI proved but not fully human proved. It's just like the reality you just mentioned. We just don't have that many people who are that knowledgeable about everything yet.
But well, I think nowadays we have something similar in the sense that some results are understood only by a bunch of people on Earth. And basically the rest of humanity trusts these people. Yes, even I heard once that there was an open problem that it was very famous maybe in the 70s or the 80s, and a few years ago one guy gave a complete proof to that, and he sent it to one of these top mathematics journals, and he didn't find any referee because it was something that was very famous like 50 years ago, and people stopped researching on that. And so there were no experts anymore. So, I mean, the proof is written, but well, maybe with AI now it's possible to check that proof, but for years it was impossible to check that proof, and even today, you know, if you see what people do in some fields, it's really, really difficult to understand. Only very few people on Earth get to know really this, right? For instance, well, in stochastic partial differential equations, one guy told me that well, he was going to give a seminar. Stochastic PDs is a very technical topic, right? And he knew an artist, and he said, I want to see your seminar. And he said, okay, you are free to attend, but you will not understand even one single word. And the guy was sitting in the back, and at the end they chatted, and so how was it? Yes, you were true. I didn't understand anything at all, but I saw you moving on the stage and writing these equations, and this is really like a great performance, right? So this is what the artist got, but you know, it's, I don't know, maybe we are going this way, unless there is some real application of the theory, and then this proves its usefulness to the rest of the world, I think.
Reactions, you can react. Yes.
I want to comment on this. If on one side proofs might be more difficult, and involve, on the other side, they might involve more people to work on the same problem, and it might be a huge problem, but once approached collaboratively, it might be approached really, while this would change the pattern from working on simple stuff, that's relatively simple, to much bigger problems. So I would like to be optimistic on that. And one question I have, because I kind of agree that if everything has a metric, then there might be no, like the system could work very easily. But at the same time, we would need clear rules for ensuring that the metric contains everything. So my question is, do we have governments that understand what's going on and what we think like? Because I think that at present, governments are not understanding enough. So that would create differences, disparities among people.
First of all, I have a comment for your comment, because because I think Terence Tao, who is one of the most well-known mathematicians, I think he has initiated a project where calls on help from everyone to help with AI proofs. That's kind of the collaborative approach you mentioned. I think we do have something like this. It's very difficult to a single or very small number of people to work on very challenging problem, but by doing that, it's possible to kind of tackle more challenging questions. And for the government one, I think it very much, I don't think the people in politicians knows too much about those things, but I think we do need people, for example, like in the UK, we have lots of advisory boards who are true scientists who advise the governments to do that. I don't think it's the job of the politicians to learn all those AI advancements, but it's the job of scientists, like professors, who advise them to kind of have a better understanding about that.
I also have a comment on the first part. So it was raised several times that we have more and more complicated proofs and more complicated theories, and it would be very hard for the humans to check it. And I think one part of the science and the research is neglected in this sphere, that the knowledge doesn't develop like we just add more and more more complex theories, but we continuously reevaluate and crystallize the existing theories. For example, I have the book of John von Neumann when he introduced the operator theory, and it's very hard to read and it's very unintelligible. So you can, if I know what he's talking about, now I can decode it, but the way how we learn it today is much more simpler, much more clearer. So that will help so AI can help in that, and it will also help to keep the complexity of the new results at bay, in check.
So in my notes, I have Goodhart's law. So when a measure becomes a target, it ceases to be a good measure. So I think we are very measure-oriented, right? All about the papers, all about results, and we do not question why, right? Why are we here? Why are we having this nice discussion? Because we are human beings, right? Why we are teaching integrals? Because there is innate beauty in integration too. It's not only about the number, right? But it's about expanding your knowledge and experience, right? And connecting it with governments, right? So there are no governments. We are all in one room, right? It's all human beings. So, just to finish our discussion, right? I think we have to talk. I don't think we have enough discussion about AI. We are scared. And it's natural, right? You are scared. We are scared. We don't know. We don't know. Will we teach? Maybe I'm wrong, but I am scared. I don't know what happens in 10 years. For me as a teacher, for me as a researcher, I don't know where that path leads. And of course, for you, it's even more complicated. So this discussion and all other discussions have to be out there. And of course, it will have a practical use because representatives of governments, of society in general, will start understanding, these complex, because yes, the masks have fallen, right? We can't lock ourselves in the ivory tower and be happy with it. We are being challenged. And yes, we have to survive. We have to adapt. I do agree, right? So thank you very much. I hope it was useful and gave food for thought, and have a nice evening.